Welcome here at Modern SQL. Today I'm going to tell you some things about the SQL standard and how the SQL language evolved over the last decades, I have to say. So I've handpicked a few features I would really like you to know. And these are really just a few features out of the standard. There was so many changes in those years, in those many years. We are talking about SQL 92 is the most common and most well-known standard, but it's really pretty old. Just 10 minutes lost, okay? I will skip a few things, like that one, lateral. It's really great, but I don't have the time right now, okay? You have it on the slides, you will see the URL. It's a nice thing, but the other one, the with recursive is more fundamental to show you. So this is what you're missing. Just one short thing about these graphs. I have these graphs through the whole presentation. They show which database started offering what feature at which year. And you see this lateral was introduced with the SQL standard release of 99. And you see that the database vendor started with a certain delay to support it. Some of them still don't support it. Okay, let's come to with. Another name for with is common table expressions. And there are two flavors of with, the regular with and the with recursive. I will cope with the regular one first. So what's the problem this with is solving for you, or can help you solving with? If you have a query like this, and you want to understand that, then you usually need to find the innermost part first. And once you have made up sense out of that, you can go one step outside and understand the next part. And then you will see, there's something joined on the same level. So you need to understand that one as well before you can finally understand the very first line of the query. And this can be rearranged using with. It's really just about formatting code, about making SQL more readable. So there's a new keyword. It's called with, and it's valid as a prefix for select. In that case, this with is really like statement scoped views. That's really what it is, statement scoped views. Instead of create view as, you just say with. And the difference is a view is saved in the database and everybody can access it. The with query is only visible to the next select query. So in that case, I specify a statement scope view called A, and I give it 3 columns. And then I have S and some query. That's it. It's really just a statement scoped view. However, I can put a comma here to define a second statement scoped query, like B in that example. And here comes the magic. This B can already refer to the just defined one, to the A. And this makes it possible to unnest queries and make them chained, which is quite handy to make it more readable. So here I have a third common table expression. And the small thing to note here is that there is no comma, and when there's no comma, then there's the main query following. So that's now just a select that can already access all these just defined statement scope views. And the difference is you read it from top to down, like we are used to read code. So we can, if we write a query, a more complex query, then we can give the future readers an idea in which order to understand it, to put it in order of human logic, or to make it more literate, if you think about literate programming. So this with, I like to compare it to private methods, because it's pretty much the same. You can use it for abstraction. You can also reuse it, but only in a very, very limited scope, one query. You can refer to them multiple times, of course. Their main use, in my eyes, is to make nested queries into chained queries just for readability. And it's basically allowed everywhere where select is allowed. It's really just a prefix to select. When it comes to the standard, it's also allowed in subqueries. And also, like I show here, insert into with select. It's just a prefix for select, nothing more. Okay, I skipped that one as well. That's just for Postgres. So this was also introduced with SQL 99. That's quite some time ago. And many databases support that for some years now. So there's actually not much against using this if you have any use for that. But here comes the more powerful version of that, with recursive. before I show you how to solve a problem with Recursive, I will show you how you solved it without Recursive. And this is what you see on this screen here. So with Recursive, you can do stuff you couldn't do before with Recursive. The example I'm showing you here is a so-called row generator. It just produces rows out of nothing. And how it does it, I will show you. So first of all, we have another new keyword. It's with Recursive, I'm checking, yeah. There's the column list. And if you have with Recursive, you need to have a union or union all inside this query you're defining. And the first leg of this union is called the initializer, and it's executed first. And in that example, it's just giving you one row with one column, which the content 1. And this 1 is then kind of sent to this common table expression and becomes visible everywhere where this common table expression is referred to. Okay, so it becomes visible twice there. In the main query, it just becomes part of the final result because that's the main query. It just returns the data to the client. But the more interesting part is in the inside, because now the second leg of this union all starts to execute, and it's executing on this one row it just got, and it's doing whatever is written there. So it says n plus 1, which makes it 2, and sends it again up to the common table expression, and there builds a loop. Okay, can you see that? Can you see that? Yeah. Okay, and this loop, well, it possibly executes until end of days. You have to make sure that, like in any loop in programming, you can have an infinite loop. So it terminates when you make it abort. So you just have to filter. Okay, if there's some number coming greater than 3, then just stop, and then it terminates. So what we have seen here is basically a loop. We've just implemented a loop in SQL. Row generators are one common example what to use it for, but the more common use case are processing graphs in the sense of social networks and so on, so like shortest distance from two people. This is the common use case for that. But to make it really more general, it's really just like loops. The only thing is you can pass state to the next iteration, which we just did with our n, which is kind of a counter. And you can have pretty complex dynamic abort conditions. So it's not like a for loop. You don't have to say, okay, make it like 10 times or for every row, but you can have a dynamic abort condition. And using this, you can do pretty awesome stuff. So I like to compare with Recursive. Okay. I need to like to compare with Recursive to while, because it's really, you can do the same stuff. You have to be careful because it supports infinite loops. Yeah. And there is some syntactic irregularity regarding the standard. However, you can basically use this in all of these databases already. So who's using one of those databases? Oh, come on. Okay. These. So who is using one of the databases that are green in here? Please hum now. Yeah, quite some. Who is using one which is red here? Please hum now. Okay, you're not admitting it, I know. Okay, so this was with Recursive, and if we summarize the standard of SQL 99, it was loops, because lateral is also some kind of loop, but I skipped it today. And with Recursive is the most generic kind of loop you can implement in SQL, directly in SQL. In SQL 99, there were a lot of more features, mostly related to object relational databases, but those never became mainstream, so I'm just skipping them at all. So let's go further. SQL 2003. That was really a big one, maybe the biggest one since 92. And the one and only feature that makes really everything different is the over clause. And the over clause is a little bit nasty, so I have made 3 parts out of it. The first one is over and partition by. I'll show you how it works. But before I show you the over clause, I'll show you the example and how you would solve it without the over clause. So in this example, I'm already using the with clause to show you this top-down way to read a query. So I'm defining a statement scoped view called total salary by department. And then there is the query. it really just goes to the employees table, it groups by department, and returns two columns, the department number and the total salary of all the employees of this department. And then there's the main query, which joins the employee table to this statement scoped view, and basically calculates how the percentage, how much each employee earns out of the complete department. So this is what's happening up in the select list there. So it's basically just the percentage of one employee out of all employees of one department. And the reason this is so strange, actually, it's a quite big query for that, is because the group by clause, like we know it, does two things at a time. First, it collapses rows with the same keys, very much like distinct does. And second, it allows you to use aggregate functions like sum. We could already use distinct without group by because we have the distinct keyword itself. But before SQL 2003, there was no way to use aggregate functions without some way of collapsing in sense of group by. And now we have it. And this is how the query looks now with this over clause. And because that's a little bit, come on. Yeah. That's not so obvious what it actually means. I will go through it step by step. So imagine this is the table. And this is the query that returns this result. If you want to use one of these aggregate functions, you just add a new column. So I'm putting a comma up there, if you can see it here. And you just use any aggregate functions you already know. It's sum, count, max, min, average, whatever you like. But you don't want to collapse the rows, so you have to use the over clause after it. And within the over clause, you can specify which rows are to be summarized. And here I'm using an empty over clause, which is very similar to an empty group by clause, and basically means build the sum over the complete result set. So what's happening here is we get one more column, and it's with the sum of all the salaries, which is 6,000. So this is over and the empty over clause. It makes the sum overall, but it doesn't collapse any other data. So the next example is over with partition by. So inside the over clause, we basically specify which rows are to be aggregated. And with partition by, we can segregate the rows very much like group by does. So if I say partition by department, then I will build groups, like in this color scheme. Okay, like in this color scheme. And the aggregate function is only applied to the rows belonging to each group. So the first one has just one row, therefore the total is 1,000. The second one has two rows, it's 2,000. And the last one has three rows, therefore 3,000. So basically, over is a postfix to aggregate functions. With the over clause, you specify for which rows the over clause, the aggregate function shall be applied. If you make it an empty over clause, you can basically make aggregate over the full result set. If you make it with partition by, you can segregate the rows very much like group by does. Then there's the next step. You can, in the over clause, you can also put an order by, which might sound a little bit strange because all the functions, the aggregate functions we know so far, they don't care about any order. It doesn't matter if you count 1 by 2, and this just doesn't matter, okay? But still there's the order by clause, and it does make sense, just for some different use case. So the example I'm showing you here is the running total. Imagine you have a transactions table, and you want to have the running total, let's say the balance, the current balance, for one specific account. One way to do it without the over would be to use a so-called Scala subquery. So that means a subquery in the select list where you just apply the aggregate, but you have to be damn careful to make the where clause right, because you have to repeat the filter on the account column here, and, which is even worse, you have to translate the order by clause into a where clause up there. So that's easy to get wrong. Tell me if I'm talking to some picture you can't see, okay? Okay, yeah. So before SQL 2003, running totals were really just awkward, and don't even think about performance. It's just a possible way to accomplish that goal, but you won't be happy with that. The real answer was always, well, damn, do it in the application. And in many, many cases, that's still a good answer. Nevertheless, sometimes you want to do it in SQL because you want to continue processing the data on the database side. So this is how you can do it. It's again the sum, and then we have the over with the order by in there. So the order by puts the rows in one specific order, obviously. And then you can specify which rows out of this complete partition you actually want to accumulate. And you can basically say, like here, I would like to accumulate the rows between unbounded preceding, which means the very first row of this set, and the current row. So you can define a so-called window here, actually a frame. And this frame changes for every line. In the first line, it's the first row only. In the second line, it's already the first row and the second line, and so on and so on and so on. So the number of rows you are accumulating is getting bigger and bigger and bigger every time. And this pretty much gives you just the running total like we wanted it. So confusingly, the order by clause inside the over clause is actually used not to really order them, as well it does also order them, but it's also used to narrow the rows you want to aggregate. Nevertheless, once you have put the rows into a specific order, some different set of functions make sense. They ain't any aggregate functions anymore. These are the ranking functions. It's a different kind of functions. So we have now finally an official way to number rows. It's called row number. So you say row number, bracket open, bracket close, over, and then you specify out of which ones. Further, you can have rank and dance rank. These are things like in sports, like if you have ex aequo placements, like first place and once more same number of points sharing the first place, okay, that's rank. It will give you twice rank 1. And the difference between rank and dance rank is whether the next one is then placed at 2 or at 3. Dance rank means there are no gaps in the ranks assigned, so that would give 1, 1, 2. And rank leaves gaps in there and gives you 1, 1, 3. So all of that is built in there in SQL already. And can you use it already? Yeah, pretty much. So almost every database used in the world can do that as of years ago. That's really something you have to use if you need it, and you have to know that. Okay, so this was over. And I just took, again, one particular feature out of this SQL 2003 release. The main focus of SQL 2003 was online analytic processing. There's a lot more to discover, but over is just the most awesome one. Let's go on to SQL 2008. I have to admit I skipped one, SQL 2006. That's just because I don't like it so much. Okay, SQL 2008. There's a new feature called fetch first. Who has ever heard of this? Please hum now. Okay. Finally, we have a standard for that. Who knows what limit does? Please hum now. Yeah. So it's basically the standard version of limit. So if we don't have this fetch first, sorry, that was one too fast. If we don't have this fetch first row now, then we can still use this row number function, which I've just told you about. So you could, if you want to just fetch the first 10 rows out of a potentially very large result set, then you could just number the rows using the row number, and then put an outer where clause on that column to just cut the result off. And you won't believe it, most databases optimize this quite efficiently. Nevertheless, it's not so beautiful. If you just type in limit 10, it's just faster. And now we have this fetch first 10 rows only syntax. That's now the official way to say it, the ISO standard way to say it. It's a little bit verbose, but well, that's the way it is. Can your database do it already? Oops. Dum. Probably yes. Oh, come on. Okay, I will just change my mode. I will just talk to this one and not to that one. Okay, that might work out better. Who knows? So SQL 2011. That's the latest release we have of the standard. Who knows what this standard, this release was about? What's the main feature of this release? It's pretty much related to the talk we have just had in the keynote. It's about time, and it doesn't work. I'm sorry, it doesn't work. Ah, here we are. So can someone measure the latency so that I know how much I need to push in advance? So offset, who knows offset? Please hum now if you know offset. Come on, you're not admitting it. Okay, offset is often paired with limit. With limit, you say, okay, I just want to have 10 rows. With offset, you can say, I've already seen the first 10 rows. Just give me the next 10. Offset the result by 10. That was no standard in 2008. Interestingly, they added the fetch first clause as an official way to limit, but they didn't add the offset at that time. And I was quite happy at that time. And then with 2011, they added offset. And I really don't like offset. And you shouldn't like it too. Does anyone know that the problems with offset? Just try it out. There are two, pardon? It's not stable. That's the main problem of offset. If you're using offset to implement pagination, then it means you are basically assuming that the table doesn't change in between you're displaying first page and the second page. If there's some insert in between, then the result shifts. So if you fetch the next page, you might see the last result again as the first result of the next page. So as per definition, offset cannot be used to correctly implement pagination. Nevertheless, offset is used for exactly that use case. It's completely bollocks. And besides that, it's making everything slower. So what else do you need? It's wrong and slow. Nevertheless, if you want to use offset-based pagination and you want to stick to the standard, then this would be a way to do it. It's obviously the most strange way to do it because I'm mixing two features here. So I'm inside limiting to the limit plus offset and outside just offsetting away what I don't need. Obviously the most strange but still standard conformant way. And since SQL 2011, we can just put in there offset 10 rows. Okay, but just because it's standard, it doesn't make it any more good. It's still giving you the wrong result, or let's put it that way, the right result for the wrong answer, and it still makes everything slow. So that's why I have this here. Can you see this? So I've started a no offset campaign. And in some seconds, you might see the logo up here. So I have printed beer coasters with the no offset campaign logo. Okay, they are here, you can grab them. And there's a URL written, and there it explains the problem of offset and also how to solve it. Okay, please, if you're using offset, or if you think offset might be something useful for you, just grab a few coasters, go to the URL and read about it. Holy shit. Okay, there are also stickers, okay? You can take stickers as well. So, nevertheless, offset is available in pretty much every database because here we are. Okay, here we are. This is the no offset. You can take coasters and stickers and everything down here. Okay, pretty much every database supports offset, which is not a good thing. I repeat, offset is evil. Nevertheless, SQL 2011 has added one more addition to a feature we have already talked about, over. There's one more flare of over. And the example I'm showing you now is the opposite of the previous one. So before we have built the running total. So we have had the transactions like plus 100, minus 20, and so on. And we wanted to have the running total. Now we make a difference. We have the totals, but we would like to have the difference to the previous row. And one way to do it without this new feature is like here. So I'm basically numbering my data set, just using the row number function. And then I'm doing a self join where I offset the row number by -1. So I'm basically joining the itself, but one shifted down. And then I can access the current balance and the previous balance at the same row and bring the difference out. So this was before SQL 2011. With SQL 2011, the same query looks like this. So there's a new function called lag, which is also a window function. So it's postfixed by the over clause. And lag obviously says just the previous row. And in the over clause, you of course have to specify an order by clause. Otherwise, you cannot say previous and next and so on. So of course, there's also a lead function. So you can also access the next row. There's also first value and last value. So the first and last values of this row. And the most generic form is the nth value. So you can pretty much access any other row in this sense. And this is also available in many, many databases nowadays. The two, if you can see it, the two yellow ones are DB2 and SQL Server, which basically can do it, but have some minor syntactic gaps. However, so that's pretty much available. And if you go to the internet, you will find the slides, and you can see if your database can't do it. Here we are. Okay. But now let's come to the interesting part of SQL 2011. Some call it time travel. The more correct term is temporal and bitemporal tables. Who knows what that is? Or put it different. Who is scared of these terms? Okay, let's see. So it copes with what we have seen in the keynote. Do you remember just an hour ago? It was said that SQL is overwriting data. That's true, isn't it? Not any longer. So now we have finally a standard conformant way to cope with the problem that writing data in SQL is destructive. It used to be destructive all the time. If you didn't want to make it destructive, you had to make your own solution to keep the history of that. Now we can just go there and we can, in a declarative way, just declare that we want to have version keeping of some tables. There are two different ways of version keeping. It's the so-called system versioned tables and the application version tables. And if you have a table that is both system versioned and application versioned, then it's a bitemporal table. So what I'm showing you here is the system versioned version, which basically means just keep track, database, just keep track of all the changes. Don't do any destructive write operations anymore. Just keep track. I add two more columns to the table. I can call them whatever I like. I named them start TS and end TS. But I also say generated always as start row at row start and row end, which instructs the database to automatically fill the timestamp when this row became valid or when the validity ended. Next, there is the period defined down there, which basically just combines the start and end into one logical unit, the period. And then finally we say after the bracket, with system versioning, and bam, everything changes. Really everything changes, but you don't notice in the first sight. Because every write operation is non-destructive from that moment on. So if you insert some data and you just provide two columns, but not the timestamps, not the start timestamp and end timestamp, the database will nevertheless fill just the start timestamp with the system time. If you update something, it will create a new row in the background for you. And it will set the start and end timestamps so they are logically correct. Okay. Of course, if you delete something, oops. If you delete something, oh my God. Yeah. If you delete something, this happens, but it will just leave the two, set the end timestamp of the second row. You see it here. And the magic is, if you select this table, if you query this table, you won't see the old data. You just see the data as of now, unless you explicitly ask to see old data. Okay? And here is the as of keyword. So you say, in the from clause, after naming a table, you say, for system time as of, and you give it a timestamp. And the query will return the data as of that time. So if you explicitly ask for it, then you will get the old data. But per default, nothing changes. You don't need to touch your data or your application. And it's just magically happening in the background. So this was the so-called system versioned tables. There's also the application version table, where the application has to take care to set the begin and end times. And there is also supporting features for these new features, like constraints, which make sure that timeframes don't overlap when they logically can't. Okay, also for foreign keys. There's a lot of tooling around now, how to cope with this problem of keeping histories in SQL databases. So it's basically solving the problem we have just heard about before. That's pretty kind of new, so to say, but the commercial databases support it more likely. So SQL Server will start it this year. They have already announced it. Oracle does it for decades almost, I think, for a really long time, but with a few syntactical changes because they implemented way before it was standardized, and now they have just a different implementation than the one which is in the standard, but it's close enough. It's really just like underscore and spaces are exchanged and things like that. So that's also something you can really use, and that was just one example of what you can do with SQL 2011. And SQL 2011 was really coping with these time problems. There are two papers I would like to recommend as soon as you can see them. They explain SQL 2011 and how to cope with temporal data in a pretty concise way. It's just 10 pages PDF. Go there, read it. It's worth. Okay. If they don't come up, then you go to the slides. So anyway, you are not capturing them right now anyway. 10? I got more. Hey, I didn't know that. I'm through. More like. So we would have 5 minutes for questions, but actually we have 10 minutes. So Lucas is looking for raising hands to ask questions. In the meanwhile, I will try to put me on there, which is probably not the best thing to do. Then I will like to put the scribble on.
How does ASOF cope with schema migration?
Not at all. That's not covered. It's so the SQL 2011 is only coping with the data, but not with the schema evolution. Yeah, I'm sorry, not everything is fixed. No more questions, come on. Should I go through the lateral?
I have a question about the system version tables and how are primary keys handled there? You would have repeated entries for the same table.
You have. I will just show you that. You have then duplicate keys in theory, but the primary key is just extended. I will show you that in here. Because there is one of the supporting features, which I skipped right now, is without overlaps. That's actually thought for application version tables, but it's pretty much the same for system version tables. So if you have an ID, and this was your primary key, like ID 1, and now you make that table somehow versioned, then you must make sure that no overlaps, no logical contradictions are possible in this table. Like here, the one entry is valid from 9 till 11, and the next one starts already at 10, so there's an overlap. And the answer of SQL 2011 is that you can define the primary key like shown in a few seconds. So you can actually use this period which you have defined, and you can say this period shall not overlap, and you are done. You see it up here? So you can use, this is actually intended for application versioned tables, but it's pretty much the same for system version tables, just automatically. That's what I mean. You're just not getting just one specific feature. You're getting really a rich tool set to cope with the problem of history keeping in SQL.
Is there a possibility to define how long the versioned entities should be available? I'm a bit afraid that my database will grow unbelievably in size because I don't know.
So that's not covered by the standard, but the vendors which implement that, I think they offer features like that.
Okay.
So in DB2, I know by coincidence that they are using a separate table for the history entries, and you can manage that separate table in whatever way you like. You can make it a partition table, and you can drop or truncate the partitions. So that's not covered by the standard, but still the vendors are quite likely to offer you a solution for that. On the other hand, this feature is most useful for more or less master data, like client names and so on. And they are not changing so often, so they are more like we can keep them. So all the implementations I've done so far on features like that, although manually done, not with those cool features, just keep it forever because it's not so big. You can keep it forever.
More questions?
Who knows that guy? Please hum now. Oh, come on. Nobody. No, the scribble. Who knows the scribble? Okay, it's the mascot of my site, usetheindexlook.com. So if you want to learn something about indexing, you can go to this site. It's a full book for free. You can just read it. Usetheindexlook.com. Also on the coaster, also stickers there. And more importantly, in context of this, is actually the one that doesn't show up. But there's also a new site, modernsql.com. This is now a new book. In the beginning, I'm writing about the new features of the new standards, which are already widely available in many databases. And there you can also find the full set of slides. So there are a few features covered in the slides which I've skipped today. And it just doesn't come up. But it's modernsql.com. And you can also grab some stickers there. And there you can read and follow me how to use those features for what problems you can solve in more efficient ways, as in both in terms of implementation speed as well as execution speed. Because most of these features, especially when we think about the over clause, are much faster at execution than the equivalent other features. So here we are. Anything else? Well, okay, so I'm still here. I hope they fixed that somehow for the next one. Other than that, thank you and sorry for the strange events here. I did my best. And yeah, please remember that SQL 92 is really, really, really old, and it's still taught in many universities, and it's still the de facto standard in many toolboxes of many developers, but it's outdated. Very much like Windows 3.1 is outdated. And there are many useful features since then, which can make you a more professional developer. So please don't ignore them. Okay? He said it. It was not me, okay? Yeah, unless you use MySQL. That's true, unfortunately. But that's not my fault. But they are also starting to move now. So they are thinking about some of the features. And the window functions are actually on the official to-do list for MariaDB, not for MySQL, for MariaDB. And the next release 10.2. So okay, thank you.